So look where I am. I'm inside a subinterval. The variation in the function is not more than epsilon, right? This is the function that is not varying more than epsilon on a subinterval. So what I'm going to claim is that f prime of ck is within epsilon of f prime of x sub k minus 1. They're in the same subinterval. The function never varies more than epsilon in this subinterval. So the Cauchy tag point is here. The tag point that comes from the mean value theorem happens to be here, but it's in between. So the function value is not more than epsilon away from what it was there, right? It's pretty damn close, is what I'm saying. Not more than epsilon away from the original tag point evaluation. So with that in mind, what happens to this statement here? Remember, this is all one gigantic absolute value. I'm going to collapse this one up here. And I'm going to get the sum. I'm going to get the sum from 1 to n. This thing I'm going to replace with f prime of ck x sub k, x sub k minus x sub k minus 1. And then with the same sigma, I'm going to take away f prime of x sub k minus 1 times xk minus xk minus 1. You see those are going to be collapsed in the next step, because this guy is not more than epsilon away from that guy. So this entire sum is going to be small. Then I get down here, I'm taking care of this guy, now I need to take care of these two. So I add the Cauchy sum, and this is just the standard Cauchy sum for the original integral, minus the original integral. Okay? Now, who would like to tell me what simple little theorem we use to dominate this gigantic expression? Would it be the triangle inequality? Yes, ma'am. So where do I draw the bars? This is a big triangle, and this is a big absolute value, so I'm going to chop it where? Here and here. So this is less than or equal to. Let me collapse this. I'm going to do two things at once. You won't see that too many times. C sub k minus f prime x k minus 1. xk minus x minus 1. So that's all of this collapsed into one term. And absolute value bar. Plus, this is the triangle inequality I'm using here, triangle inequality. The thing below. Well, the thing below is controllably small, right? Because the partition is supposed to be finer than delta 1, and that makes this thing finer than 1. Epsilon. Okay, so now everyone happy? This is where we're at now. After application of the triangle inequality and collapsing the top. Okay. Since the partition is finer than delta 2, how big is this? Never more than epsilon, is it? So do we have a problem? Some of these things could be negative. I'm going to put them all in as positive. Okay? I'm overstating the case, so I put them all in as epsilon. And this is just delta xk. So if I sum up epsilon times the sum from 1 to n, delta xk, what do I get upstairs? Or sorry, x minus a is what I get, right? Get x minus a? Remember, that's the part. I'm partitioning ax now. Okay? And what's this one? Well, geez, by by virtue of the partition being finer than delta 1 of epsilon, and the expression having a Cauchy integral, this is just less than epsilon. I can make that as small as I want. And when I do, I have shown that way back when here, this and this are equal, right? Therefore, the Cauchy integral from a to x of f prime of t dt is the antiderivative of antiderivative value, which is part 2 of the fundamental derivative calculus, Cauchy stuff. They all go this way. If you follow this one, they all kind of have the same character. Okay? We have to present formulas. Well, there's some exercises here. Oh, we don't want to do those things. We already did that. Can we do exercise 2.32? Calculate f prime. Show it's continuous on 0, 1. And then calculate its Cauchy integral. That's a nasty function. It's the sine 1 over x function, isn't it? With some other crap. I want to do this problem because it illustrates a very weird thing. You can have a function that's continuous except at 0, and then wildly goofy at 0. But if you multiply that function by x, it makes it continuous. And if you multiply it by x squared, I think it makes it differential. So sine 1 over x is awful. You know, if you define the function, the topologist sine curve is defined as sine 1 over x for x not equal to 0, 0 for x equals 0. And it is the class, the reason they call it the topologist sine curve is it is an example of a set. The graph of that function is a set which is connected but not pathwise connected. Naively, people think if a set is connected, you ought to be able to draw a path between any 2 points. Well, you can't. So the subtle distinctions in connectedness and pathwise or arcwise connectedness break down for the topologists. When you study complex variables, you do contour integrals, where we're doing vector line integrals around paths. You want to make sure that the domains which you're operating in are pathwise connected. Because if you run into one of these damn things, well, it's not a rectifiable curve either. It has infinite length. And yet the whole thing is sitting right there in a little piece of space. But no problem. Boss, we can make it continuous, I think. So we have a topologist sine curve. Let's call it T for topologist. Tau for topologist, right? We'll say it's sine 1 over x if x is strictly greater than 0 unless it equals 1, and 0 at 0. Okay. And then look at this function and look at this function. And the function they give us in the book is essentially x cubed times that. So that's okay. Would this function be continuous? I think it would be. Do you think it's continuous? How is it prove it's continuous? At 0. Continuous from the right.
Okay, if the limit of power is 0, then the limit of x times tau x at 0 is the limit of x times the limit of power x.
we sure about all these things? You know, when limits don't exist, some of those limit theorems don't work.
You're gonna use exclusive.
Well, how about just a straightforward computation? If you pick an epsilon, this is what the graph of the thing is. You pick an epsilon, right? I'm gonna pick a delta. All I have to do, since the sign is...
What I was gonna say is, if the limit of the power vector of 0 is then product of limits is the limit of yeah, the product of limits is the limit of b, and then limit of x is x equals 0 is 0. And the limit of
What is
it's got to be between 1 and minus 1.
Limit doesn't exist in present.
Limit something.
So how do you pull the theorem?